Hi guys, I trust that you're all feeling great and lovely. Welcome to this video on grade 10 mathematics, and in this video we're going to be having a look at products. So it's going to be a relatively shorter video, but there's some content that I need to cover because I've had a couple of people who are struggling with products, and the aim of this video is to go over the basics. So we're going to have a look at the introduction of what products are. We're going to have a look at what happens when you multiply a monomial with a binomial or trinomial. We're also going to look at what happens when you multiply two binomials. Then lastly, we have a look at what happens when you multiply a binomial with a trinomial. If these terms sound rather strange or unfamiliar to you, don't worry. We'll have a look at each of them. Without any further ado, let's get into it. So in grade 9, you'll be introduced to the different types of expressions. So for example, if you've got 3y plus 2, let's say minus 4x, you were taught in grade 9 that this is an expression, and we've got different names for expressions based on the number of terms that we have in the expression. An expression with only one term is called a monomial. Now remember, in English, the prefix mono means one. That's an easy way to remember it. So an expression with one term is called a monomial. An example would be 4. It's an expression with only one term. You could have minus 3x squared, that's still an expression with one term. You could have 6 minus x plus 2. This is still one term, despite the fact that in my denominator I seem to have two terms. You would remember that if I had something like x plus 2 over 6, this would not be a monomial, because if you look at the numerator, you can separate it and have something like x over 6 plus 2 over 6, and these are two terms. However, it would not be the same if you had to say, for example, if we take this example and you said 6 over x plus 6 over 2. This is absolutely wrong. But anyways, we're not here. An expression with two terms is called a binomial. Examples of binomials would be 3 minus y, x squared plus 6x, negative 4 plus 14, etc. We have expressions with three terms which are called trinomials. Now pay attention to the trinomials, because these are the type of terms or expressions that you'll be dealing with quite a lot in grade 11 as well as in grade 12. You have an example like x squared minus 6x plus 4. You can also have something like y to the power 3 minus 6 y to the power 2 plus 4x. This is still a trinomial because we've got 1, 2, 3 terms. In the first example, we've got 1, 2, 3 terms. These are examples of trinomials. I hope that this makes sense to you guys, and I hope that you understand the difference between the three types of terms, the three types of expressions. This is just a revision of what we did in grade 9. We have what we call like terms. So what are like terms? These are terms with the same variable or same variables, and those variables have the same exponents. I'll give you an example. Let's say we take a binomial, 3x squared minus 6x squared. Notice that both of these terms have x squared in them. They've got x, meaning the same variable, and that variable has the exponent of 2. So we've got the same exponents. These are what we call like terms. Another example would be something like 14k to the power 12 p to the power 4, let's say plus 6k to the power 12 p to the power 4. These are still like terms. Why? Because we've got the same variables k and p, and each of these variables have the same exponents. K is an exponent of 12, k is an exponent of 12, p is an exponent of 4, p is an exponent of 4. I hope that this makes sense. If I could have something like, let's say, 3p to the power 6 q to the power 4 minus 17 p to the power 4 q to the power 6. These are not like terms, because in as much as we've got the same variables, there's p here, there's p here, there's q here, there's q there, the exponents of those variables are not the same. P in the first term has an exponent of 6, p in the second term has an exponent of 4. Already, because the p's do not have the same exponent, these are not like terms. Notice that we said like terms can be added and subtracted. Now, how do we do this? If you look at the first example where we've got 3x squared minus 6x, I could simply say, because these are like terms, let me subtract the coefficients. 3 minus 6, this is going to give me minus 3x squared. If we look at the second example, we've got like terms. So I can simply say, let me take the coefficients. 14 plus 6, this is going to give me 20k to the power 12 p to the power 4. In the third example, because these are unlike terms, we cannot add or subtract them. So please take note of this. Only like terms can be added and subtracted. In grade 10, we will look at the multiplications of terms in details. Now take note of something. We did not say we're looking at the multiplication of like terms. We did not say we're looking at multiplication of unlike terms. In fact, we can multiply like terms and unlike terms in exactly the same way. So the multiplication of terms is not dependent on whether or not we've got the same variable and the same exponent. They can be different variables with the same exponent, or they could be the same variable with the same exponent, or the same variable with different exponents. Alright, let's have a look at what happens. What do we do when we multiply a monomial with a binomial or a trinomial? So to multiply a monomial with a binomial or trinomial, we need to multiply the term outside the bracket with every term inside the bracket. Please take note of this. The term outside of the bracket must be multiplied with every term inside the bracket. In other words, the way I like to think of this is we need to distribute the monomial. So by saying we're distributing the monomial, we're saying every term inside of the bracket, every term inside the binomial, every term inside the trinomial receives a copy of the term outside of it, multiplication. When we do this, we need to multiply the coefficients of the monomial with the coefficient of the term we're looking at. I'll show you an example in just a second. After multiplying the coefficients, if the term has the same variables or variable as the monomial, we need to add the exponents. If we could look at a very quick example. If I have 3x to the power 4 into, let's take a binomial, 12x to the power 6 minus, let's say 7x to the power 4. What I simply need to do is I need to say, okay, for the first term here, 3 times 12, this is going to give me 36. Then what do I do with the x's? Because we've got the same variable, x here, x there, I add their exponents. The next step, I will say 3x to the power 4 multiplied by minus 7x to the power 4. So 3 times minus 7, this is going to give me negative 21. We've got the same variable, x and x. So I can put x and then I add their exponents. So whenever we multiply, we add the exponents. This rule is going to come back again a little later on when we're having a look at the topic of exponents. But for now, keep in mind that when we multiply our monomial with the terms inside of a bracket, if we've got the same variable, add the exponents. If the monomial and the terms have different variables, include each variable in the product. What does that mean? Let's say I've got 3y into 4 minus 6k. I'm still going to multiply my exponents. I'm still going to multiply my coefficients. 3y times 4, I'm going to multiply 3 times 4. This is going to give me 12. There's a y here, but there's no y there, so I'm just going to bring down the y as it is. Then I move on. 3 times minus 6. This is going to give me minus 18. There's a y here, but there's no y, so bring the y as it is. There's a k here, but there's no k there. We just bring the k down as it is. I hope that this makes sense. Let's look at some examples. So there we are, 2x into 3 minus y. Let's go to our writing pad. So we have got 2x into 3 minus y. We said we are multiplying a monomial with a binomial. So what do we do in such an instance? Well, we multiply the term outside with the term inside. 2 times 3, this is going to give me 6. There's x here, but there's no x there, so I just bring down the x as it is. Right. Next, I say 2x times minus y. I multiply the coefficients. 2 times minus 1, this is going to give me minus 2. There's x here, there's no x there, no problem. I just bring the x down as it is. There's a y here, there's no y there, no problem. Bring the y down as it is. There we are. We have multiplied out the brackets. This is our product. We are done. Life is great. Wonderful. All right. The next example. Negative 6x squared into x squared plus 2x plus 1. Let's go back to the writing pad. We've got negative 6x squared into, but that's a terrible 2, into x squared plus 2x plus 1. Right. In this example, we are multiplying a monomial with a trinomial. So what do? We said we multiply the monomial with every term inside the bracket. Negative 6x squared times 1x squared. I multiply the coefficients. Negative 6 times 1 gives me negative 6. I've got x squared and I've got x squared. I've got the same variable. So what I need to do is I need to add their exponents. Then I move on. Negative 6x squared times 2x. Multiply the coefficients. Negative 6 times 2, this is going to give me negative 12. I've got x squared and I've got x. Same variable, so I add the exponents. This is 2 plus 1. We know that if a variable or a number does not have an exponent, we always assume the exponent to be 1. Next step. Multiply the term with the last term. So, negative 6x squared times 1. This is going to be negative 6 times 1, negative 6. I've got x squared, but I've got no variable there, so I just bring down the x squared as it is. Wonderful. We can now simplify by adding our exponents. So this is 6x to the power 4 minus 12x to the power 3 minus 6x to the power 2. Wonderful, we are done. If we look at this, do we have any like terms? Well, we've got x to the power 4, x to the power 3, x to the power 2. We've got the same variable, but each term has a different exponent. Therefore, there are no like terms. We leave it as it is. If it happens that we had like terms, we would have to add or subtract them, deal with the like terms first, then simplify. All right, let's move on to the next question. Here's a simple one. 3 into 12 plus 4x plus 5y. All right, we have got here 3 into 12 plus 4x plus y. Sorry, this is supposed to be 5y. So, what do we do here? Once again, we multiply the term outside the bracket with every term in the bracket. 3 times 12, this is going to give me 36. Multiply the term outside the bracket with the term inside the bracket. 3 times 4, I'm multiplying the coefficients. This is going to give me 12. Since I have x here but no x there, I'm just going to bring down the x as it is. Next, 3 times 5y. 3 times 5, this is going to give me 15. There's a y here, there's no y there, so let's just bring it down as it is. Do we have like terms in this expression? No, because we have a constant, we have x, we have y. None of the terms share a variable with the same exponent, so we just leave our expression as it is. Wonderful. Let's go to the next question. So, the last question for this section, here's an interesting one. k squared into negative 3k to the power 4 plus 5k to the power minus 1 minus 7k to the power 4. All right, let's go and write this down. So the question we are given here is k squared into negative 3k to the power 4 plus 5k to the power minus 1 minus 7k to the power 4. Okay, same procedure we've been following. Multiply the term outside the bracket with the term inside the bracket. So, k squared times negative 3k to the power 4. When we multiply out the coefficients, we will get negative 3. There's a k here and there's a k there, so I put the k as it is and I add their exponents. Wonderful. Next step, multiply the k squared with the 5k to the power minus 1. Multiplying the exponents, 1 times 5, this is just going to give me positive 5. We have k squared and we have k, so this is k to the power 2 plus minus 1, like that. Lastly, multiply the term outside the bracket with the term inside the bracket. K squared times negative 7k to the power 4. Multiply the coefficients. 1 times negative 7 is just going to give me negative 7. I've got k squared, I've got k to the power 4. Let me add their exponents. So this is going to give us negative 3k to the power 6 plus 5k to the power 1, which is just 5k, minus 7, let's see, k to the power 6. Looking at this, do we have like terms? Well, yes, we do. We've got negative 3k to the power 6. We've got negative 7k to the power 6. Why are we saying these are like terms? Because they both have the same variable, and that variable has the same exponent in both terms. So what do I do here? I could say minus 3 minus 7. This is going to give me minus 10k to the power 6 plus 5k. I can now omit the exponent of 1. Alright, I hope that this makes sense. I hope that you guys are understanding how to multiply a monomial with the binomial. I hope you're enjoying the content. I hope you're finding this productive and that you're learning from it. If you are, guys, a lot of you are watching this and you're not subscribed. Please give us a like and please subscribe to the channel so that you get notified every time when we upload new content, and also to support the growing of this channel, to support the work that we do, because honestly, it's not easy creating these videos, but we believe that we are helping people out there. So with your support of just subscribing to the channel, you would be helping us a lot in continuing the work that we do. Awesome. All right, we've got one more question. Let's have a look at this question on the writing pad. Let me scroll down and let's copy down the question. So we have got, let's see, this is for p to the power 5, q to the power 2 into 7, pq minus 4, p to the power 3, q to the power 5. Okay, looking at this question, we follow exactly the same procedure. Multiply the term outside the bracket with the term inside the bracket. 7 times 4, that's going to give you 28. We start by multiplying out the coefficients. We've got the same variables in each term, so we say p to the power 5 plus 1. The 1 is coming from the exponent of p here. Then we say q to the power 2 plus 1. We are now adding the exponents. Next, this multiply by that. 4 times negative 4 is going to give me negative 16. This is going to be p to the power 5 plus 3, q to the power 2 plus 5. If we simplify this, we're going to get 28 p to the power 6 q to the power 3 minus 16 p to the power 8 q to the power 7. Wonderful. Do we have like terms here? No. Why? Because we've got p to the power 6 and p to the power 8. Already, because we do not have the same exponent on each of the variables, we call it quits. We don't have any like terms, so we leave our answer just here. I hope that makes sense to you guys. If you do have any further questions on how to multiply a binomial with a trinomial, multiplying a monomial with a binomial or trinomial, please leave them in the comment section and we shall attend to you. Alright, now we're looking at multiplying two binomials. So multiplying a binomial is as simple as multiplying every term in one binomial with the term in the second binomial. This is very similar to what we did with multiplying a monomial and a binomial. We can also use FOIL to multiply out the brackets. To multiply out the binomial. So what does FOIL stand for? FOIL says to us, multiply the first terms of each bracket. Then we multiply the outer terms of each bracket. Then we multiply the inner terms of each bracket. Then we multiply the last terms of each bracket. If this does not make sense, don't worry, we'll have a look at them just now. Once again, when we multiply terms with the same variables, we multiply the coefficients, we add the exponents. Time for an example. Alright, here we are, 2 plus 3y, 6 minus 4y. Let's have a look at it on the writing pad. I'm going to open up a new sheet of paper here. Alright, so what do we have here? We have got 2 plus 3y multiplied by 6 minus 4y. Now notice that both these terms are binomials because each expression in the bracket has two terms. I'm going to show you two ways of doing this. Here's the first way. We can multiply every term in the first binomial with every term in the second binomial. In other words, I could say, let me take the 2 and multiply it with the second bracket. Let me take the 3y and multiply it with the second bracket. We are following exactly the same procedure we did when multiplying a monomial and a binomial. So 2 times 6, that's going to give us 12. 2 times minus 4y, this is going to be minus 8y. Brilliant. 3y times 6, this is going to give us positive 18y. Then 3y times minus 4y, this is going to give us minus 12y squared. Do we have like terms? Yes, we do. We've got negative 8y and 18y. So what do we get when we simplify this? We're going to have the 12 as it is, minus 8y plus 18y, that's going to give me positive 10y, minus 12y squared. Brilliant. So this is the first way we could use to multiply out the expression. Let me show you the second way, using FOIL. So we've got 2 plus 3y into 6 minus 4y. Remember what we said with FOIL, multiply the first terms. So 2 times 6 is going to give us 12. Multiply the outer terms. So 2 times minus 4, this is going to give us minus 8y. Multiply the inner terms. 3y times 6, this is going to give us positive 18y. Multiply the last terms. 3y times minus 4y is going to give us minus 12y squared. Already you are seeing that what we have in this step resembles what we have in that step. So we could just go on by saying, okay, we've got like terms of minus 8y and 18y. So we are going to have 12 minus 8y plus 18y. This is going to give us 10y minus 12y squared. And there we have it. You could use any of the two approaches, Personally, I prefer to stick to FOIL because I find it to be much shorter. So I'm going to stick to FOIL for the rest of the lesson. Alright, let's move on and check what our next question is. X plus y, 6 minus m. So, we have got x plus y, 6 minus m. Using FOIL, we multiply the first terms. X times 6, this is 6x. Using FOIL, we multiply the outer terms. X times minus m is minus xm. We then multiply the inner terms. Y times 6, this is going to give us 6y. Lastly, we multiply the last terms. Y times minus m is minus my. Alright, when we look at this, do we have any like terms? Well, no. Because we've got 6x, okay, we've got x there, but there's an extra m. So we cannot take these two to be like terms. If we look on the other side, we've got 6y and my. We cannot take these two to be like terms because they've got two different variables. Therefore, we are done solving this expression. Wonderful. Let's look at the next question. M minus 2 squared. I love this question. Alright, so we have here m minus 2 squared. You would remember that we said 4 squared is the same as saying 4 times 4. X squared is the same as saying x times x. So, m minus 2 squared is the same as saying m minus 2 into m minus 2. Let me put this on the next line. So this is going to be m minus 2 into m minus 2. Now we can multiply it out. M times m, FOIL, first term, m squared. Multiply the outer terms. M times minus 2, this is minus 2m. Multiply the inner terms. Minus 2 times m is minus 2m. Multiply the last terms. Minus 2 times minus 2 gives us positive 4. Do we have like terms? Well, yes we do. We've got minus 2m minus 2m. So, we could say this is m squared, then minus 2m is going to give us minus 4m plus 4. There we have it. We have solved the question. Life is great. Let's look at the next question. Alright, the last question that we have for this section. Negative 7 into p plus 4 squared. Okay, so this is kind of a combination of the two multiplication of terms that we've looked at so far, the two ways of simplifying products that we've looked at so far. This is a combination. Whoops, this is supposed to be p plus 4 squared. Okay, let's have a look at what happens here. The first thing I can do is let me say leave the 7 and let me deal with the two brackets. Because remember, BODMAS says to you that you need to always deal with the brackets first before you can deal with anything else. So if you had to decide to multiply the minus 7 in first, that would be wrong. Because the squared is restricting you from multiplying in the minus 7. So let's pretend the minus 7 is not there. Let's leave it there and FOIL. Multiply the first terms. P times p, that's p squared. O, multiply the outer terms. P plus 4, that's going to give us 4p. P times 4, sorry. Then multiply the inner terms. This is p times 4, that's still going to give us 4p. Multiply the last terms of the outer, multiply the last terms. 4 times 4, that's going to give us 16. Once again, ignore the 7. Then we have p squared. Then 4p plus 4p, that's going to give us 8p plus 16. Now we can come back and stop ignoring the poor 7. Negative 7 is just sitting there being poor old negative 7. What we can now do is we could see that we can multiply in the negative 7 the same way we were doing initially when we were multiplying a monomial and a binomial. So let's have a look at this. So this is going to be minus 7p squared, because we're saying minus 7 times p squared. Then minus 7 times 8p, that's negative 56p. Then minus 16 times 7, that's going to be negative 112. There we are. That is a terrible 2. There we are, ladies and gentlemen. We are done simplifying this question. Life is great. This takes us to our last section, multiplying a binomial with the trinomial. This one is very similar to multiplying two binomials. In other words, multiply every term in the binomial with every term in the trinomial. When multiplying the coefficients, once again, if it's coefficients of terms with the same variables, when multiplying terms of the same variables, we multiply the coefficients and add the exponents. Let's look at an example. Okay, you will notice now that we have an increasing level of difficulty because it's no longer a setup in which we have just the simple questions that we've been doing with, where we've got exactly the same type of, the same number of terms in each bracket. This is not multiplying a monomial or a binomial. So let's see. M squared minus 4, and we have m cubed minus 6m squared plus 4. Let me go to the writing pad so you guys can see what I'm doing. Okay, now I'm going to multiply m squared with m squared. M squared with m cubed. When multiplying these two numbers, we add the exponents. 2 plus 3 is 5. Next, m squared times minus 6m squared minus 6m to the power 4. Next, m squared times 4, that's going to give us positive 4m squared. Next, negative 4 times m cubed, this is negative 4m cubed. Negative 4 times negative 6m squared. This is going to be, let's see, 6 times 4, that's going to give us positive 24m squared. Lastly, negative 4 times 4, this is going to be negative 16. Now we need to check, do we have like terms? Yes, we do. We've got 4m squared and 24m squared. We can actually go ahead and add these. We are going to get m to the power 5 minus 6m to the power 4. Then 4 plus 24, that's going to give us positive 28m squared minus 4m cubed minus 16. There we have it, ladies and gentlemen. We've answered the question. Life is great. Alright, in this question, as you can see, we've got the x plus 2 squared into x plus 3. Let's go over to the writing pad and see how we can do this. So over here, what I would do is, first of all, we know that the squared here means I need to multiply the bracket by itself twice. So this is going to be x plus 2 into x plus 2 into x plus 3. Now, you will notice that I'm multiplying 3 binomials. What I could do is, let me first multiply out the first 2 binomials. Then I'm going to leave the second one as it is. So, using FOIL, x times x, that's going to give me x squared. X times 2, that's going to give me positive, this is positive 2x. Then 2 times x, that's going to give me just positive 2x. And then 2 times 2, this is going to give me positive 4. I've got like terms in my expression. The like terms that I have in this instance, I've got positive 2x and positive 2x. When I add these two, I am going to get, this is x squared plus 2x plus 2x, this is going to give me 4x plus 4. Then I'm going to remain with x plus 3. Now, in this instance, what I need to do is I need to multiply every term in the trinomial with every term in the binomial. So I'm going to start by saying x squared times x. This is going to give me x to the power 3. X squared times, this is supposed to be x squared times 3. This will give me 3x squared. Next, 4x times x. This is going to give me 4x squared. Then 4x times 3. This is just going to give me 12x. Lastly, I have to say 4 times x. This is going to give me positive 4x. Then 4 times 3. This is going to give me positive 12. Okay, let's try and see if we have any like terms in this expression. We have got 3x squared and 4x squared. Also, there's a second set of like terms that we have here. We have the 12x and the 4x. So when I deal with these like terms, I am going to get x cubed remains the way it is. 3x squared plus 4x squared, this is going to give me 7x squared. 12x plus 4x, this is just going to give me positive 16x plus our constant. There we have it. We have simplified the expression. I hope that this makes sense to you guys. All right, let's look at the next question. So here we've got the product of a binomial and a trinomial. K plus 4 multiplied by k squared plus 9k plus 18. Let's go to the writing pad and write this out. So let me open a new sheet of paper. So there we are. Then the question that we had was k plus 4 into k squared plus 9k minus 18. All right, we multiply the first two terms. K times k squared, that's going to give me k cubed. Then we say k times 9k. This is going to give me a 9k squared. Next, I say k times minus 18. This is going to give me minus 18k. Next, 4 times k squared, this is going to be positive 4k squared. Then 4 times 9k, this is going to give me positive 36k. Then lastly, 4 times 18, this is going to give us negative 72. Let's identify if we have like terms. Let's check if we have like terms. There's 9k squared and there's 4k squared because they've got the same variable and the variable has the same exponent. We also have minus 18k plus 36k. So let's see, if we simplify this, I'm going to have k cubed. Then 9k squared plus 4k squared, that's going to give me positive 13k squared. Then minus 18k plus 36k, this is going to give me positive 18k. Then lastly, I have negative 72. Wonderful. Life is great. So let's look at the last question for this section. So we've got p minus 1 into p squared plus p plus 1. Let's have a look at this one. So let's scroll down a little bit. We have p minus 1 into p squared plus p plus 1. As we've said before, multiply the first term in the binomial with the first term in the trinomial. So p times p squared, this is going to give me p cubed. Then p times p, this is going to give me just positive p squared. Next, p times 1, this is going to give me positive p. Negative 1 times p squared, this is going to give me negative p squared. Negative 1 times p, this is negative p. Then negative 1 times positive 1, this is going to give me negative 1. Let's identify like terms. We've got p squared and negative p squared. We also have negative p and positive p. Now when we look at this, we've got p cubed here. P squared minus p squared, that's going to give us 0. P minus p, that's still going to give us 0. So we remain with minus 1 here. And there we are, we've solved the question. I hope that this made sense to you guys. I hope you enjoyed the video, and I hope now that you have a better understanding of products. And if you do understand it much better, please give us a like, please give us a thumbs up, please subscribe to the channel so that you can get notified every time when we make new content. Also, please share this knowledge with other people. Please share the video with other people so that they may also benefit from the same knowledge that you are experiencing, from the same knowledge that you're gaining here. Thank you so much for watching. Until next time, ciao.